All right, there was a portion of the note packet that I realized I had missed, and I do apologize. I'm going to go ahead and make this short video to fill in this little portion all about physical properties, intensive versus extensive. All right, so a physical property is basically a property that can be measured or observed. Measure or observe. So for example, behind me the wall is green. That's easy to tell. That's a physical property. Right now I'm doing this video on top of a table. This table is actually relatively cold right now to the touch. It's also very smooth. It's black. It's hard. It's a typical lab table. Therefore, those are all physical properties. I could tell that by touching it or by looking at it. Just to make sure we're clear, that is different from a chemical property. A chemical property is not something that's easy to tell. You can't just look at something and say, oh, that powder is flammable or combustible. Maybe if you know what that powder is, maybe you know from previous knowledge that it might be combustible, but having no experience with that particular substance, you can't just look at that and say, oh, that's highly explosive. There are clear liquids that are very flammable, but they look just like water. So that's a chemical property. The fact that it is a clear liquid, again, is a physical property. The fact that it is combustible or flammable is a chemical property. So that's the difference between the two. Now, of physical properties, there are two types. There is intensive and there is extensive. An intensive property is a property that does not depend on the quantity of the object that you have in your hands. So an intensive is basically inherent properties to that substance. You could have a little bit or you could have a lot of it. It's all going to be the same. For a weird example that just popped in my head, if you were to go into the ocean and get a little bit of the salt water in your mouth, you know that the flavor of that, right? The taste of it is not very good. It doesn't matter if you're at the ocean, which is like the Atlantic or the Pacific or whatever. It doesn't matter if you're just drinking a small glass of similarly mixed salt water. It doesn't matter if it's a little bit or a lot, it's all going to taste very salty, right? Another thing I was thinking of is like Play-Doh or clay. You could have a little bit or you could have a lot. Either way, it's malleable. You can change the shape of it. You could squeeze it. You could. It's going to have a particular color. You could have a big glob of it or just a tiny amount of it. Those properties do not depend on the amount that you have. Now that is different from an extensive property. An extensive property is dependent on the quantity that you have. For example, a rope, the length of a rope would depend on how long it is. You could have a 2 centimeter long rope, or you could have a 2 foot long or 2 meter long rope. That is a extensive property, the length. It depends on, well, how long the rope is. The color of the rope is an intensive property. It doesn't matter how long the rope is, the color is going to be the same. An extensive property is you could take that rope and you could weigh it on a balance, and it could say, okay, it's this many grams. That would depend on the quantity of the rope that you have on the balance. That's an extensive property. Another example would be the volume of a substance, let's just say that the mass of a water. You could have a little bit of water or a lot of water. The mass is going to be different. That's an extensive property. So that's kind of the difference between intensive and extensive. At the bottom of this part right here, it wants you to create a Venn diagram. I thought it'd just be easier to find one and to insert it. So here you go. Voila, that was easy. So on the left side we have our extensive. Again, it depends on the amount of the substance, like it says on the left side of your screen. Examples include size, mass, length, shape, volume. On the right side of your screen you have the intensive, again, which does not depend. It is an inherent quality of that substance. That includes smell, color, density, ductility, phase, malleability, boiling point, melting point, and density. Those, again, are just inherent to that particular substance. Now, what is true to both in the middle of your Venn diagram is that they can be observed, changed, or measured without altering the identity of the substance. And that is only because they're both physical properties. If you could measure something without destroying it, that is a physical property. In order to measure the flammability of a liquid, there's really only one way to do that, and that's to light it on fire. That again is a chemical property. Physical properties, again, do not destroy the substance that you are trying to measure. And of course, intensive and extensive, obviously this is very generic, but can be used to describe matter. So that's a physical property and the sub part of that, which is intensive and extensive. Again, I'm sorry that I skipped this part of the notes, but I hope this helps.